So a real quick test here. So raise your hand if you're kind of an automation user, or that's kind of your primary background, kind of from the user side versus the supplier side. So users, okay, and suppliers, okay. So the test is, I just figured out, anybody that didn't raise their hand must be asleep right now. So a couple hours after lunch, so I know how the afternoon can be. So we're at a very exciting time, I think, in the automation field, and so I'm very happy to be able to be here and talk about some of the challenges that we're facing, but I do agree very much with the challenges that Haresh just went through. We see those, he's seeing those from the manufacturing side. From the power generation side, we see those exact same challenges, and I do believe those are opportunities for us, as he said. So just real quick, give you a sense of Tennessee Valley Authority. Of course, Tennessee Valley Authority, for anyone who remembers their history from school way back, was established with the New Deal by Roosevelt in 1933, and we are the nation's largest government-owned power provider, and in fact there's only a couple of government-owned power providers in the country today. We are funded entirely by power sales. It was established in 1933. All the funding was stopped from the federal government for power production in 1959, and since then it's been self-sufficient. We have a power system about 37,000 megawatts, combination of fuel types you can see listed out there. A little over about 250 different units across those fuel types at different locations. We serve 7 states. You can see our primary service territory is in Tennessee, and then pretty heavy in Alabama, Mississippi, and Kentucky, as well as a few others. About 9 million people. And Tennessee Valley Authority is a little bit unique from some here who are vertical integrated utilities. We do not actually serve distribution customers. So what that means is we generate the power, we have all the transmission lines, and then we serve power to about 155 different municipalities or co-ops around our service area, as well as about 56 industrial or federal government customers, which are large facilities. And so example of an industrial customer could be an Alcoa plant, for example, would be an industrial customer that we would serve. So kind of gives you a sense of the business that we're in. Our initial days were very heavy on the hydro production, so particular with Tennessee River, there's a lot there as far as hydro production. So the perspective that I've come at this from kind of on operational technology or industrial control systems, as Dick mentioned, we think of that as all the digital assets and systems that perform these 4 functions: control, monitoring, diagnostics, and protection. So if you think through all the different systems in your plant, that's kind of how we start it. We have some flow charts, and that's how we evaluate which systems are considered OT systems. Here's some examples of different systems. Y'all are familiar with a lot of those. Some unique characteristics of OT systems, and when I say unique as compared to maybe an IT or a typical business system, there are, of course, real-time plant production systems, high availability, very often redundancy built in, fault tolerant, very specialized, and there are unique regulations and security needs with OT systems compared to maybe other architectures you see out there. So I want to kind of talk about a few challenge areas, and we definitely see the exact same business and culture type challenges that Haresh mentioned. These are kind of the 3 I wanted to kind of focus on today. The complexity of automation systems today. There's both positives and negatives that come with complexity and the capabilities of systems today. Cybersecurity and then strategic planning, or some would call that maybe life cycle management. We look at that to include life cycle management plus some other things. Before we get into that, I also want to, just a reminder, as you're thinking about challenges and how you're going to address challenges and what they are, it's important to remember for an OT system, what are the overall goals? And if you back out at the very big picture, we view OT systems as primarily focused on these 3 goals here for our plants. We first want to maintain safety, reliability, and efficiency. Obviously, there are a lot of other goals that fold into those that relate, to compliance and environmental regulations and other things, but these are the three overarching goals. And so if you start looking at those and you start looking at things like system complexity and having a very complex system, and you start thinking that one of your goals is to have a safe and reliable system, you can see how those start to clash at times. Because a good friend of mine likes to say that complexity and robustness are inversely proportional. And I think there's a lot of truth in that, and there's a lot of value in keeping things simple. So these are the goals. So with that, let's kind of go through these three different areas of challenges. So starting with system complexity, here's some of the things that lead to system complexity. So from our perspective, the evolution from proprietary to the off-the-shelf technologies, all of us have experienced that. And just when you go from a proprietary control system that's developed hardware and software all together, maybe by one vendor, and maintained production line for the next 15 or 20 years, versus a more open system, maybe you might say today, that comes with less expensive hardware that may run on a commercially available operating system that we all typically use in the control system environments. And then the servers and start thinking about all the elements that go with those type of networks and systems, and you very quickly end up with a very complex structure system. Also, we tend to end up with a mixture of both those modern systems and then legacy systems, because you put in a new control system, you don't go change out every single I&C device or component in a plant facility in most cases. So you end up with a mix of systems. So now you've got these different technologies, and maybe you try to make them integrate together some, and that may work to some extent and not in other cases. And so routable networks and business connectivity, there's great benefits that come with this, as there's many presenters here who can share a lot more about some of the business integration that's possible. We all rely upon data for troubleshooting and analysis of our plant systems out there in different industries that's based on data that comes from a control system and funnels up into some business system and maybe combines with other data along the way. But all of those connections and interfaces, again, start to add to the complexity of the system. Open architecture and third-party interfaces. So I mentioned these legacy systems, but we very often end up with a primary control system at one of our power generation facilities, for example, and then lots of secondary systems, and there may need to be some level of interaction and communication between those, and you end up with lots of different, OPC interfaces, Modbus interfaces, lots of other alphabet soups and acronyms we could throw out for those interfaces. Again, those start adding to the complexity because each one of those carries with it different versions and compatibility issues with those upstream systems. And then the higher degree of automation and capability. So these systems that we buy are very capable. Sometimes we utilize the capability fully, sometimes we don't. I've been involved in a number of projects where the primary objective at the beginning of the project that's provided is maybe to make this new control system and this new technology work exactly like the old stuff that we're taking out. And we've all been involved in those type of arrangements, and so very often you end up not using the capability, so you end up not getting the benefits of the new control system, but you do get the complexities and the challenges of managing it. So you end up there sometimes with the worst of both worlds. And if you do utilize it, you end up often with a higher degree of automation, and there's great benefits that come with that, but it's also worth just noting that it does add complexity in some cases. And when it adds that complexity, some of the consequences that we see with regard to power generation, and I believe from talking with some here at this conference, other conferences, this applies across other industries. You definitely have a great increase in both the breadth and the depth of the expertise that's required to work on that system and to install it. That gets into Haresh mentioned the IT/OT discussions. These OT systems require a lot of what we in the past would call an IT skill set to work on and maintain these things. And there can be can be good sharing there, and that depends on how that's done and how companies are organized, and you get into a lot of different elements as far as how you maybe are geographically organized and as far as how you're organizationally shaped in your company as to how well that works and how that needs to be done. There's much greater difficulty in configuration management with new systems. There's many more parameters, many more aspects of things that can be changed. And so many times you end up needing essentially a configuration management system to manage the configuration of your automation system. It's not always done adequately within the control system itself. Increased training needs. With these more complex systems and with a higher degree of automation, it becomes even more critical that you train people. Very similar to the power industry is the airline industry, who spends a lot of money on simulation and training. And for all of us that maybe took a plane ride here or back, we're very thankful for that focus they put on that. And within the power industry, that's very important because we want our electricity to be reliable as it is here in our country. And so those training needs add on other systems that you have to maintain, and then you have the complexities of making sure the simulated system matches the real system, and as changes happen to one, has to be reflected in the other. And so that's a very important thing. And I think then maintenance cost obviously ties in with all this. How do you maintain these systems that are changing maybe at a more rapid rate than systems that you had 20 years ago? And then greater risk in managing abnormal situations. This one certainly applies between the airline industry and the power industry and probably most other industries. As you get a more complicated automation system, it's great when you have, even to the extent that you have a plant where you can push a button and start the plant up from beginning to end. But what happens when something doesn't respond as expected and the operator is not used to manually observing things and making manual corrections to processes? It becomes very critical and ties back with this training need. You can find yourself in a very bad situation very quickly when the automation system does something unexpected, or when an input fails, or maybe even someone just thinks that an input has failed and it actually hasn't. And so managing abnormal situations becomes one of the real great challenges. And I think it's an opportunity as well, because the automation systems today certainly have the capabilities to recognize some of those abnormal situations and help prevent improper actions even in those cases. So moving on to the next kind of broad area, cybersecurity. As if there weren't already enough fun challenges in the automation world, over the last 15 years, cybersecurity every year seems to sort of ratchet up to a new level. So I kind of wanted to start out here with kind of a broad overview or perspective of cybersecurity, and this aligns with many of the standards out there. Obviously, there's lots of different types of threats, and just having threats out there alone, is not the most significant concern. We'd love to not have threats, but those threats obviously have to first act upon vulnerabilities. And vulnerabilities could be things like unpatched systems, unsecure access points, portable media, maybe a USB stick that someone brings in and plugs into your control system. And then those vulnerabilities actually then lead to abnormal operations in some cases. Some cases they don't, some cases they do. But if they do, that can look like things like maybe the automatic control response is improper. Maybe there's an improper manual response because of the inaccurate data that was presented to the operator, who then made a manual operation. And then those abnormal system operations have the potential of undesired consequences. So, you could have abnormal system operations that do have a consequence and then some that don't, and degrees in between. And those could be everything from safety to environmental to equipment damage. A story about your plant on CNN, it could be lots of different things like that that are undesirable. So, cybersecurity. Security alone is kind of one aspect of cybersecurity, and then you have compliance, which the compliance piece is continuing to increase in recent years. And with automation systems, I think it's important to remember this model of people, process, and technology. We think of it as kind of the success equation is that you combine people and process and then you multiply it with technology. So technology becomes sort of the multiplying or leveraging factor for how you apply people and process. If you apply the people and process well and multiply it with technology, the results become even better. If you apply people and process with less than desired conditions and you multiply it with technology, it can become really bad. And in the case of security, when you're trying to balance these two balls here on top of this pyramid of compliance and security, the way we've explained this within our company and at other forums I've been involved in is the more you can get security and compliance to overlap with each other, the better it can be. And so if you can primarily be focused on putting in good security, and then as doing that, your byproduct essentially is compliance, and you can, with minimal excessive effort, hopefully reach compliance, that's the desired end. Now, the reality, as we all know, is compliance requires paperwork, it requires reporting, it requires other stuff. Sometimes it may even require something that's not necessarily a best security practice in some cases. You know, there could be something that's a compliance requirement that could impact security in a negative way even, and so or not benefit security at all. So that's just something to think about on the security challenge. So some specifics as far as security. These are some what we consider to be some of the best practices out there for OT systems, and many of those do overlap with security defenses. And this is certainly not an exhaustive list, but at the top of the list there you can see standardization and lifecycle strategies. And I do believe that, I really strongly believe that standardization is a big part of security. Obviously there's a security weakness if you have all of your eggs in one basket, everything's in one system. You can suggest that that is a security weakness. But if you go to the other extreme and you have so many different types of systems that you can't have expertise and you can't maintain patching and you can't configure systems properly, you can very well end up with a very complex system that is very unsecure. The next area, I'm not going to go through all these, but the next one I do want to mention, network segmentation. I believe that network segmentation and the access controls into your equipment, those should be very high priorities. If you haven't started into a major security program, those should be at the very top of the list because you very much need to understand the assets you have, how those are connected together, and hopefully provide some segmentation so that people can only access the appropriate parts of networks or systems out there. Some of these others through here, you can see like device and software inventories. That becomes a very challenging area if you have a geographically spread out fleet of plants, whether that's in, as Suresh has, in different countries or if that's in different cities. Keeping a real-time status of what are the different systems that are installed and connected to the network is not an easy challenge by any means. And again, it ties back to this people, process, and technology, even in the security area. That's really what you have to rely upon. And there's a couple different strategies that I see being taken out there in security, and I wanted to kind of highlight that. And I'd say that sometimes people start on one end or the other end of this, but oftentimes you see security that is very heavily based upon isolation that's on the left side. And when you have isolated systems, they very often end up becoming more unmanaged or less managed in a real-time basis, because the more isolated they are, if they're in extreme isolation of completely being disconnected, then providing any type of a cost-effective monitoring and management of those systems can become very challenging. At the other extreme is kind of the fully connected and fully managed systems that can provide some centralization benefits for some companies. And in the case of connected systems, you have to rely upon additional defense in-depth measures to secure those systems if they are connected in some way. in particular if they have to come back to a corporate network, maybe through other companies' systems or networks out there. In the end, from some of the projects and programs I've been involved with, I believe that having a connected system ends up supporting a much more automated cybersecurity program. Certainly, you can be more proactive and have much more integration. There's a balance there between having a more connected system versus a system that's in isolation in how you maintain that security program. The cost of putting a security program in versus the cost of maintaining a security program with these two different approaches kind of depends upon the location of your assets. It depends, how far are they spread apart, how your organizational structure is set up. Are you going to support those locally or support them centrally? There's a lot that has to factor into that. So, next, I want to talk about this strategic planning piece. And I think this is really, to me, if you were to pick one thing and say, where do you need to start to have a really good operational technology or control system program at a company level, I believe this is really the foundation block here. And some reasons that you need that, obviously improving planning for some of these system lifespans. The lifespans have gotten shorter. At the same time, it's no longer just calling your control system vendor and finding out how long they're going to support the system, because they're depending upon multiple other parties, whether that be the operating system vendor, the hardware vendors, the technologies related maybe to their I/O cards and the underlying board technologies there. Another reason is if you have a strategic plan, it provides a framework for establishing very clear roles and expectations on who's going to provide which functions relative to your control systems or your operational technology. I've seen in cases where you have major failures with automation systems, or where you have improperly maintained systems or safety events that occur, very often it goes back to this, is there was not very clear expectations on who was doing what with that system, maintaining it, keeping it upgraded, keeping it tested, performing preventative maintenance on it. Those type of things can really result in some catastrophic impacts if you don't think about them. Risk-based assessment of critical systems. There's, depending upon the system, whether you're talking about a broad PLC system or maybe a DCS or some other type of single loop systems, for your primary systems, I think it's very important to take a risk-based approach and define criteria of how are you going to assess the HMI, or how are you going to assess the I/O component of your system or the network component of your system. And I think there's a lot of information out there on how you can go about defining those criteria and creating sort of some quantitative criteria so that you can take lots of different plant systems or even different plants that are in different locations and compare their automation systems so that you can get people onto a sort of an equal playing field, and you can decide where you need to be investing your capital funds for upgrades so that you're not upgrading systems that maybe are not the worst or not the highest risk within your fleet of systems. So the elements, when I talk about a strategic plan, obviously a roadmap of the systems and technologies, this risk-based criteria, and then mitigation systems, and then this funding plan. So overall, if you were starting and trying to really build an effective as well as a long-term sustainable control system, operational technology, or automation plan, I think this developing and executing this strategic plan is obviously a very important element. Leveraging the capabilities of technology. Don't put in a system, obviously, and not utilize all the benefits of it. And we see that as something that, the new technology there's continuously new technology, but technology very quickly today reaches a point of maturity that it's ready to be more widely adopted. You don't always want to be the very first adopter of everything, but you don't want to be, sitting here today not yet using any bus technology or not yet using some of the advances of the last 15 years. Integrating cybersecurity into the culture and to the business processes. So this goes right back to what Haresh was speaking of. Culture is one of the most difficult aspects, I think, of automation, of how do you change the culture. It takes a lot of focus and effort. Executing projects with consistency and technical excellence. So this looks like having standards, having consistent approaches of how you do project management when you execute projects. I know at this very same session last year, there were some great presentations about automation projects and how you can be more successful in executing those projects. And then finally, and this one ties back again with the IT and OT in particular, but even broader. But on the internal, this IT and OT, I think collaboration is the real key to that. There's not a single answer for every industry or every company that, it should be mix of IT and OT maintaining the control systems, or that it should be one or the other. But I think what you really need is a good collaboration and a team effort between IT and OT organizations so that you can come together and figure out what are the areas where IT can help the control system groups manage their systems, and what are the areas that don't make sense or where their skill sets and their processes may not be the best fit. And then don't neglect to utilize the external resources. The conferences, there's lots of different industry groups, whether you're talking about cybersecurity, operational excellence, system integration, how you do automation projects. There's so many resources today that we have at our fingertips, and utilizing those, I think, is the key for us. So with that, Dick.